Hi, my name is Michelle Swigert, and I will be reading Chapter 4 of Addiction and Grace by Gerald G. May, MD. And it is Love and Spirituality in the Healing of Addictions. And if you are on this video, that means you have been tuning in with me for the previous chapters. And if you haven't watched those and you want to start from the beginning, go to the playlist and go by chapter. That way you know what's going on, right? So, full disclosure, very smart words. Trouble saying those smart words. So please bear with me and show me a little grace and mercy, okay? All right. Chapter 4, the neurological nature of addiction. A mind is a system of ideas, each with the excitement it arouses, and with tendencies impulsive and inhibitive, which mutually check or reinforce one another. William James. That's his quote. It says most people nowadays are trying to give up the distinctions that used to be made among mind, body, and spirit. Neurological science has effectively demonstrated that mind is brain and brain is body, and many theologians have recovered the old Hebrew sense that humans are beings who are souls rather than bodies that have souls. These developments have brought a welcome holism to modern thought, but we should not forget that mind, spirit, and body are not exactly the same thing. Human beings are certainly not made up of compartments, but neither are we conglomerations of undifferentiated mush. If we are trying to understand ourselves at all, we need precision in how we describe ourselves. Even Eastern religions, which have never compartmentalized human beings as Western society has, establish clear distinctions among different aspects of the human person. One might assume that Western society, with its great emphasis on science and its long history of compartmentalizations, would be very precise about such things as mind, body, and spirit. But nothing could be further from the truth. Compartmentalizations of the human being have brought us confusion instead of clarity. Richard Restack, a neurologist and widely read author, tells a poignant story about the great neurosurgeon Wilder Penfield's struggle with these distinctions. On a hill near his house, Penfield had painted symbols for spirit and brain on a large rock. He connected the symbols with a solid line. Later, just 6 months before he died, Penfield climbed the hill again and replaced the solid line with a dotted line. This account, and others recorded by Restack, demonstrated how many neuroscientists can be perplexed by conflicting understandings of mind, spirit, and soul, and the like. Much of the time, the problem is language. The old Greek word, psyche, is one of the worst culprits. It has been used for both mind and soul, sometimes for spirit, and even for the Freudian Jungian unconscious. The German Geist, meaning both mind and spirit, can be similarly confusing. To semantic complexity, we must add the results of a modern neurological research, which makes distinctions between mind and body virtually impossible. Most scientists, and many theologians as well, find such confusions intolerable. Out of frustration, one is tempted to jump to the abrupt and arbitrary, as in this statement by French neurologist Jean-Pierre Jongua. I probably butchered that, sorry. Man no longer has a need for the spirit. It is enough for him to be a neuronal man. Semantic confusions could be helped a great deal by careful research and accurate definition of terms. But the problem goes deeper. Neurologists can be very precise about the brain. And theologians can define terms clearly, but when it comes to the more mystical dimensions of human spirit, those transcending the body and reflecting the divine, theologians as well as neuroscientists face a real struggle. The human spirit, for example, is both pervasively indwelling and yet immutably rooted in the eternal, like God. It has at once qualities of immanence and transcendence. It is our life force as incarnate beings, and yet it is also more. According to Genesis, our human spirit is the breath of God in us. If so, it not only gives us the life we have, but also calls us toward a more perfect and whole life, a life of growing freedom and love. Thus, the human spirit is the source of our yearning, as well as our very life. I have not found it easy to bring spiritual understanding into meaningful harmony with the hard data of anatomy and physiology. This is not because of any inherent split between spirit and matter. Instead, the problem comes from my own attitude. I can marvel at the wondrous creation that is the human body. I can try to grasp the fact that the atoms that make it up are almost completely filled with space. I can even appreciate the spiritual nature of the fundamental energy out of which both space and material are made. These are all mysteries to me. The workings of the brain are mysterious in the same way. Yet I easily become intoxicated with how much we do know about them. Our knowledge has expanded by quantum leaps in the last few years, and the more I learn of it, the more I am entranced by the possibility of finally knowing everything there is to know about it, and thereby being able to master and control it. It reminds me of the serpent's seduction of Adam and Eve. Eat of the tree of knowledge, and you will become like gods. I find it difficult to walk the line between seeking to expand my knowledge and expecting that knowledge to save me. The truth, of course, is that the farther our The truth, of course, is that the farther our knowledge of a thing expands, the more mysterious it becomes. Modern physics has discovered this, and in the process, physicists have become less hard and objective. They have become more like artists. The neurosurgeon Wilder Penfield exemplified it as he tried to draw his perceptions of the human being on a rock. Ultimately, we cannot grasp everything in its entirety. Yet we would do ourselves and our Creator a great disservice if we did not explore the mysteries of life with every resource available to us. As I describe how the brain functions in addiction, then I will be as accurate as I possibly can. As I describe how the brain functions in addiction, then I will be as accurate as I possibly can. I shall also use a metaphor now and then, not simply to make a point more clear, but also because I am convinced it will add to the truth of what I am trying to portray. The next part of the section is called the cells of the brain. Like every other part of the body, the human brain is made of cells. There are many kinds of cells in the brain, but most significant are nerve cells or neurons. Each neuron can be considered a living being in its own right, with its own unique life and experience. Each has its own energies, activities, rhythms, and of sleep and wakefulness. Even its own initiatives early in its life. Each neuron is capable of movement and reproduction. Each consumes nutrients, breathes oxygen, gives off carbon dioxide and other waste, and responds to the activities of other cells and to substances in its environment. During its lifetime, a neuron is born, matures, learns, ages, and eventually dies. Neurons both initiate and respond to a wide variety of electrical, magnetic, chemical, and vibratory stimuli. The brain as a whole can be seen as a colony. in which billions of these tiny cells live. Within this great community of cells, neurons form complex societies according to their location and function. The key to any brain activity is the way thousands or millions of these cells interact in logic or local groups and functional systems. Local groups of neurons are collections that are located close together in the same areas of the brain. Cells in local groups may or may not work together. Functional systems are made up of cells that do work together to accomplish certain tasks. They may be located close together or at some distance from one another. Some functional systems are primarily made up of cells within a certain local group. For example, the cells involved in thinking a single abstract thought may be located quite near one another in the frontal lobe. A similar group of cells in the parietal lobe, P-A-R-I-E-T-A-L, that's the word, parietal lobe, may register a simple touch or temperature sensation. In the same way, a group of cells near the inside center of the brain affects body temperature, and another group nearer the spinal cord is important in governing the level of wakefulness and attentiveness. That's a mouthful. A lot of this is a mouthful for me. But most functional systems involve the collaboration of cells that are widely separated within the brain. Hearing a particular song and having it remind you of a time in the past, for example, involves the cooperation of cells in the inner ear, parietal lobe, there's that word again, frontal lobe, temporal lobe, and a number of other areas as well. An individual cell is likely to participate in activities with nearby cells in its local group as well as with faraway cells in different functional systems. The body of such a cell will be located in a certain geographic area of the brain, but it will send a long fiber or axon to another part of the brain to connect with other cells. Next section is a lot of big words. Synapses, neurotransmitters, and neuroreceptors. Synapses. S-Y-N-A-P-S-E-S. Synapses? Okay, we're going to call it synapses, okay? In order to work together, nerve cells need to communicate. They send messages through connections called synapses. An average neuron has 20,000 of these connections with other cells. Some have as many as 200,000. At each synapse, communication takes place when the axon of one cell releases a chemical called neurotransmitter. This chemical passes across the tiny synaptic cleft between the cells and is received by a chemical structure called a neuroreceptor on the next cell. In addition to responding to neurotransmitters from other cells at synapses, neuroreceptors are also sensitive to chemicals such as hormones that are produced elsewhere in the body and circulate through the bloodstream. Foreign chemicals such as caffeine, nicotine, narcotics, and other drugs also reach neuroreceptors through the bloodstream and can exert powerful influences on the neurons. And the next section is called the complexity of the brain. No one knows for certain how many neurons exist within the normal human brain. They are literally uncountable. The best estimates range from 10 billion to 1 trillion. We do know that neurons begin to form early in fetal life, and that by the 10th week of gestation, they are multiplying at enormous speeds. Since all the neurons of the brain are formed by the time of birth, they must develop at a rate of at least 150 per second throughout the 9 months of pregnancy. If neurons have an average of 20,000 synapses each, the total number of synapses in the brain is in the order of 500 trillion. Such numbers are incomprehensible. If we had a supercomputer that could count 1,000 synapses each second, it would take between 10 and 15,000 years to come to the total for one human brain. Wow. To this magnitude of numbers, we must add the incredible complexities of how nerve cells and their synapses actually function. Approximately 30 different neurotransmitter chemicals have been identified thus far, and more will surely be discovered in years to come. Although a given cell normally produces only one kind of neurotransmitter, it is likely to have receptors for a wide variety of transmitter chemicals. Thus, a particular cell may be involved in many different functions and will respond to many different stimuli simultaneously. In addition, communication among cells is not a simple one-way event. Through an important mechanism called feedback, cells often respond to the messages they receive by affecting the cells that sent the messages in the first place. Feedback changes the kinds of degrees of messages being communicated and helps maintain the important balances we mentioned in the example of congestions and decongestions in Sally's nose. The messages carried by a specific neurotransmitter may stimulate, inhibit, or facilitate a cell's activity. The structure of the neuroreceptor on the receiving cell determines which of these effects a certain neurotransmitter will have. Thus, one neurotransmitter chemical may stimulate one kind of receiving cell, inhibit another, and facilitate yet a third. Out of this vast array of interactions, human experience and behavior arises. All thoughts and feelings, all sensations and memories are mediated by the transmission of electrochemical energies along the bodies and fibers of nerve cells and across synapses. The unique pattern of each mental function are determined by which nerve cells and synapses are active, in what sequence, and what neurotransmitter chemicals are released and received. A simple knee-jerk reflex may involve only a few 100,000 neuron synapse connections and perhaps only one or two kinds of neurotransmitter chemicals. Complex activities requiring thought, judgment, and action require millions or billions of connections along with multiple neurotransmitter chemicals in an orchestration so intricate we could never hope to decipher it completely. All the varying interactions form dynamic systems within systems which mutually affect one another to produce arrays of possibilities approaching